Hi everybody, today's video is going to start off with the basics of parabolas as well as how we can graph them, and then in the second video we're going to talk about writing their equations and an application problem for this type of conic. So just as a review, we want to know what a conic section is, and that's basically what you get from slicing a cone in different directions. I've got this picture here that kind of describes or shows what it looks like. We've already talked about the circle, and that would be if you slice a cone horizontally. And what we're going to talk about today with the parabola is when you would slice it diagonally and then where it goes through the bottom. So you guys have seen parabolas before. We're just going to be taking it up a notch. The other thing I want to review are two formulas you guys have used many times, the distance formula and midpoint formula. If you don't already know those, you might want to add those to your notes just to refer back to. And then more importantly, from last semester and maybe even Algebra 1, we talked about the two major forms of a parabola, the standard form, which is probably the most familiar, where you have ax squared plus bx plus c. That looks something like y equals 2x squared plus 6x minus 7, or the vertex form of the parabola, where you have x minus h squared and then the plus k at the end. And remember, the vertex is the point hk, where the h value changes signs. And all of those formulas were mainly for parabolas that open up and down. And so we are going to be introducing parabolas that can also open left or right. So that's kind of the new thing that we're going to be focusing on. The points or pieces of a parabola that we're really going to make sure we pay attention to and that we understand. Some of them are going to seem familiar, some are going to be new, so I draw this diagram into your notes. The first one is the vertex. The vertex is the middle point of your graph. Usually it's the maximum or minimum, but of course when we start going left to right, we wouldn't call it a max or a min anymore. But this is just an ordered pair directly in the middle of your graph. The other thing you guys have seen before is the axis of symmetry, and this is the line that splits your parabola directly in half. So we call that the AOS, or axis of symmetry, and that is a line. In our notes today, this is either going to be a vertical line or a horizontal line. Okay, and then we have two new pieces that we want to talk about. The first one is what we call the focus. The focus is a point that's always inside your parabola, so you might want to add that to your notes. It is always in line with the vertex, and it's always going to be on the axis of symmetry. And the focus point is a point where if you were dealing with like parabolic satellites or anything like that, maybe flashlights where a light is being reflected, that focus point is going to be where those signals or rays or anything like that are going to bounce and hit. So if I send signals down into my parabola, they all bounce back to that focus point. The other new term related to the focus is what we call the directrix. And this is a line, kind of like the axis of symmetry. The directrix, let me write that here, is always perpendicular to the axis of symmetry. So if you notice, the directrix is never going to cross the parabola. Definitely want to add that to your notes. So never crosses the parabola. Okay. It's always opposite directions of the axis of symmetry, and it is the same distance away from the vertex as the focus. This distance that we have here is called P. So P is the distance, I'm writing this out for you guys, from the vertex to focus or to the directrix. Those are the same distance no matter where it goes. So P is a length, maybe 5 units, 20 units, whatever is given to you. And you're going to use that P value in your equation that you guys will see here in a little bit. So focus and directrix are new. Vertex and axis of symmetry, those should be review for you all. Here are the two new forms of the parabolas that we're going to be talking about. They're called what we call the transformational form, and there's two different versions because now we're going to have graphs that either go up and down like we've always done, or they're going to go left and right. And so when I'd go ahead and write both versions down because you're going to use both. The up and down version, the one we're most familiar with, is when we have an x that's squared. So notice that in my equation it starts off x minus h squared equals 4p times y minus k. So remember, the vertex is still going to be h comma k, just like it was in the vertex form from our last units that we did. The new thing here is that p-value. And remember, we said p was the distance from the vertex to the focus or vertex to the directrix. And I wrote that down here again in case you didn't get it on the last slide. So that's going to be really important when we're writing our equations or when we're graphing. And then the left or right, this is the new one. It is the same formula except that y and x get switched. Same with the k and h, they get switched. So instead of x squared, it's now going to be y squared. So y minus k squared equals 4p times x minus h. Everything else in the formula stays the same. The p-value is still from the vertex to the focus or directrix. You just flip-flop the variables. And then the only other thing I would add into this, and I made a note of it down in the bottom left, is that the reason it's 4p there is that's what we consider the width of a parabola. And when I talk about the width of a parabola, I'm talking about the distance from one point to the other, from one side to the other, through the focus. Okay, so if I'm talking about the width, I start at the focus and I go left and right a certain direction. So that's going to be really helpful when I'm having you guys graph to save you a lot of time. Instead of having to make a big long table of plugging in points, you can use that 4p value to plot some points and then connect your dots. And that should save us quite a bit of time. If you haven't already noticed, I put this picture here in this corner. I just wanted to show you guys an example of a parabolic satellite. This is one of the largest satellites. And if you notice that up at the top here, there's this little receiver hanging. You could consider the receiver like the focus of a parabola. So all of our signals come down, they hit the satellite, and they all bounce back into that focus receiver. So it's kind of cool how they use them. Parabolas are used in numerous things, but satellites is a big, commonly known use. So let's go ahead and practice 2 examples of graphing, and then we'll get into the next video of writing the equations. So in example 1, I give you x plus 2 squared equals 8 times y minus 1. I went ahead and listed the 5 things that I'm going to ask you guys to find in order to graph. And as you find them, you can plot them on the grid. That's up to you. The first is always the vertex. Remember, when we look at an equation, we have to see what the h value and the k value are. So when I look at my equation here, I've got positive 2 and negative 1. That means our point, our vertex, will be at negative 2, positive 1. So we're going to switch both values from either positive to negative or negative to positive, and that's going to be our vertex. So negative 2, positive 1. And I always put my labels with my points when I plot them, just so I can keep track of all my units or all my pieces. The other thing you want to figure out is the direction. So you want to know, is it up and down or is it left or right? And the easiest way to tell that is by the variable that's squared. So if I look here, I have an x that's squared. That means my options are up or down. And to determine if it's up or down, we look at the number here in front. That number is positive, which means it's going to be up. So if it was negative 8, I'd say this graph was going to be going down. And the reason direction is so important, one, that can save us time when we're plotting points, but that's also going to tell us where we can put our focus or our directrix. So that will save us a little bit of time here in a minute. So the next thing I'm going to work on is the axis of symmetry. The axis of symmetry always goes directly down the vertex point, and it's always going to go the direction that it opens. So it says it opens up, so I'm going to draw my line up and down. And when I ask for the axis of symmetry, I want the equation. So that's going to be the equation x equals negative 2. Notice that the axis of symmetry equation, in this case, matches my x value from my vertex. If this was going left and right, it would match my y value because we have a horizontal line. So it's going to switch depending on the direction your graph goes. The focus and directrix, the newer pieces to our puzzle, those come from, remember, that 4p value in our equation that we talked about. So to find the focus, you have to know what the distance is. So the easiest way to do that is to take that number in front of our equation, that 8, and set it equal to 4p. Okay, so it's always going to be equal to 4p. If I solve for p, I get that P is equal to 2. So what that tells me is I'm going to go up 2, since my direction was up. So I'm going to count up 2 and plot a point, and that's going to be my focus. So that ordered pair is going to be at -2, +3. If the graph were opening down, then I'd count down 2 and put my focus. So it's whatever direction you stated at the beginning. And then the directrix is going to be the opposite way. So if I went up 2 for my vertex or focus, I'm going to go down 2 for my directrix and draw a horizontal line. And remember, the directrix is always opposite of the axis of symmetry. Since my axis of symmetry was vertical, my directrix has to be horizontal. And that's going to be the line y equals -1. So now I have all my key pieces. The last step is to actually graph the parabola, because we don't actually have that curve drawn in yet. So the shortcut I told you guys I was going to show you is to take that 4p value. We said 4p was 8, and that is the width of the parabola. So that's from one point to the other through the focus. That was on the last slide. So what I'm going to do is I'm going to start at my focus, and I'm going to count over 4 to the right and over 4 to the left to make a total width of 8. So I'm going to count over 1, 2, 3, 4. So there's a point, and do the same thing going the other way. 1, 2, 3, 4. There's a point. And these are just 2 random points on your grid. You could try making a table to get these values, but obviously you're going to have to do a lot of plugging and solving. So instead, if you know what the width is, you can plot those 2 points and then connect them to your vertex. And now you have a parabola. So remember, when you're dealing with the width, that's a new thing, a new shortcut. You have to go from the focus and go left and right, or up and down depending on the direction, not from the vertex. If you go from the vertex, you're going to have a flat parabola, and you don't want that. Okay, and remember, when you connect your points, the focus never touches anything other than the axis of symmetry. So it's kind of floating in the middle. So when you draw your lines, make sure you connect it to the vertex, not the focus. So that's it for graphing. I want you guys to go ahead and try this one. If you try it and you want me to check it in class, go ahead and show me. I will make sure you did everything right. The key here is knowing your vertex and direction and being able to figure out what P equals. Okay, so if you have any questions, let me know. But then go ahead and watch the second video on writing equations of parabolas.